All right, we're going to start an intro to calculus, starting with the limits of a function of a real variable. And we are going to test you on this on May 19th. We're only doing 3 sections. I think it's just 3 sections of this chapter, but we're breaking it down nice and slow for you. All right, so you don't need to write these notes down. I'm just going to show you on Desmos. We're just going to explore for just a minute. I'm going to have you look at a graph and also look at the table of values. And so let me just show you. I'm gonna go to Desmos. I'm gonna put in this equation, and then I'm gonna also choose a table, and I'm gonna type in a whole bunch of x values, 1 and 1.5 and 1.75, all of these x values here, and then I'm gonna look at those x values. All right, so let's come over here and okay. So here's this equation. F of x equals 0.5x plus 3. And so it's a straight line. That shouldn't be a shock to you, where, 3 is the y-intercept, and then it's got a slope of 1/2 or 0.5. And so what I want to look at is as you get closer and closer to a certain x value, what are your y values? So I'm looking at this table, and I'm going to, I guess I should have done it slower, but like when x is 1, then your y value is 3.5. And when it's 1.5, then your y value is 3.75. And when your y value is 1.75, it's 3.875. And we're getting closer and closer, 1.85, 1.95, you're getting 3.975. And 1.999 gives you 3.9995. I skipped over 2, but if I go to 2 I go a little past 2. 2.001 is 4.005. And so as I'm coming, as my x values are getting closer and closer to 2, coming from the left or even coming from the right, my x values are going closer and closer to 2. What are my y values getting closer to? And so that is what we're going to be looking at today, is when we look at that table of values, as the x values get closer to 2, what do the y values get close to? 4. Yeah. And so as x approaches 2, we say y approaches 4. And this idea has a name. And in fact, we would have at this point in class shown you the clip from Mean Girls right at the very end when she's in that competition and she's looking at it and they go, what's the limit? And then she ends up saying, the limit does not exist. And they're like, yay. Anyway, so right now is when we would have shown you the clip. Can't do it because we're on YouTube and they'll block the video. So, all right, so let's go back to Desmos now. I'm going to put in a different equation because you're probably asking me, why would I go really close to 2, right? Why didn't I just plug in a 2? Well, here's where truly limits come into play, is if I were to go and plug in x equals 2 into this equation, you would have 2 times 2, so a 4 minus 5 on the top, but in the bottom, you would have dividing by 0, and that's not okay. But we can investigate further, and that's where limits come in. All right, so I'm going to go back to Desmos, and we're going to put in that, I want to turn that one off too. We're going to go back to Desmos, and let's look at this graph of 2x minus 5 divided by x minus 2. All right, so do you see that when x is 2, well, I've got 2 different things happening. I've got, zoom out the other way. I've got this half of the graph on the left. It's going and going and going and going up. And on this part of the graph from the right, it's going down like that. So let's look at the table of values this time. Same table of values. Yeah. But now, like when x is 1, you've got 3, your y value is 3. When x is 1.5, your y value is 4. When x is 1.75, your y value is 6. When x is 1.99, 1.85, you're at 8.667, right? But then at one, you're getting closer and closer to 2. I can't even get it to show up on the graph because it's way too far up. Do you see this? When x is 1.99, your y value is 1002. So it just zooms up super far to a positive value. If we come, if we jump over 2 and we go to 2.001, my y value is negative 998. It's way down there. At 2.05, my y value, let's see, is here at negative 18. And at 2.01, I've got a y value of negative 8. So what you can see is that things are happening differently depending on which direction you're coming from. So we're wanting to investigate what is happening as your x value gets closer and closer to 2. Well, it depends. It depends on if you are coming, you can picture this like as a ride, right? If I'm coming on this ride and I'm going, I'm zooming up to a very large positive numbers. On the flip side, if I'm approaching x equals 2, but from the right coming this way, I'm on this right, my y values are getting super duper negative, large negative values, right? So it depends. That's where it comes in of Katie saying the limit does not exist, because from the left, you're going to positive infinity. From the right, you're going to negative infinity. And so we've got, there's actually like a vertical asymptote happening at x equals 2 because of that x minus 2 in the denominator. So that is what is happening with this guy. All right, so when we look at that graph and the table of values and we answer the same question, as the x values get closer to 2, what do the y values get close to? Well, we would have you discuss with a partner, but maybe you can call a friend right now and discuss it with them, or keep going. So it depends on if you're approaching 2 from the left or from the right. From the left, your y values were going to positive infinity. From the right, we say getting very small, but really they're getting very large, but in the negative direction. And so we say the limit doesn't exist because from the left and from the right, they're going to 2 different spots, 2 different places. If we ask it, now this is a completely different question. Yeah? So first of all, from the left, from the right, your y values are going in different directions. One's going to positive infinity. From the right, it's going to negative infinity. And so the limit does not exist because they're going to different values. We can ask other things though too. So that was as x is approaching 2, and 2 made a vertical asymptote right here, right? But instead, what if we ask, what happens as the x values go to positive infinity or negative infinity? What happens to the y values? So let's go back and look at this graph. So now it's a different question. Before I was asking as x approached 2 right here. Now I'm asking as x goes to positive infinity. So I'm going down the line. Like, look, even at when you're at 10, you're right here. And if you keep on going and you keep on going and you keep on going, do you see all of these guys? Like, your y values are pretty much staying. They're getting very close to 2. And also, as x goes to negative infinity, as your x values go to negative 10 and then negative 20 and then negative 30, and if I keep on going, do you see that your y values are just approaching 2 as well? And so that is what's happening. So we can ask as x is approaching a specific value, like 2, or Or another one is we can ask, okay, what happens as x goes to positive infinity or negative infinity? Which do the y values get close to? And in this case, it is a 2. If you remember horizontal asymptotes from previous chapters, the degree on top is a 1, the degree on the bottom is also a 1, degree meaning the exponent on the x's. And so your horizontal asymptote was y equals the leading coefficient. That is not a coinkydink. That is why this is, your y values are getting close to 2, because there's a horizontal asymptote happening there. All right, so these ideas of x values getting close to something and then the resulting y values getting close to something is the idea behind a limit. Now you can actually start writing notes. Here's the notation. It looks scary. I know it looks scary, but don't be scared. It's the limit of f of x as x approaches a. And that's the notation for it. You'll write the word limit. You'll see down below in littler writing x with an arrow. A is going to be some number. You know, it would be like x as x approaches 2, or it might be as x approaches positive infinity or negative infinity. And then f of x is your function, and then we'll have some value if it does exist. So let's use the graph again. We're going to use the graph, and I'm going to go back onto Desmos, and I want to find the limit. So my f of x function here is x cubed. Hopefully you remember a cubic, right? Looks like a swimmer stroke with your right arm up. And I want to look at, as x approaches infinity, positive infinity, what's happening to your y values. Keep in mind, when they are asking you for the limit of something, it is your y values is your answer. It's as x is approaching this, what are the y values approaching? That's the answer to a limit question. Same thing here. I'm going to also look at y equals x cubed, and I want to see what are the y values. What's happening to the y values as x goes to negative infinity? And then I'm also going to look at inverse tangent, also as x goes to positive infinity, and then as x goes to negative infinity. All right, so let's go back to the Desmos graph. And back over here, and I'm going to erase these guys. Bye-bye. Bye-bye. Okay, let's look at x cubed first. Here is x cubed. And okay, so here's x cubed, right? Swimmer stroke with the right arm up. And the first question asked, as x approaches positive infinity, so as your x values are getting bigger and bigger and bigger, what's happening to your y values? And hopefully you see that as your x's are getting bigger, zoom out, your y values, you see, are getting very, very, very large. Look, here we are all we're at it right here. I haven't even reached 2 yet, and I'm already at 6, and then that's not what I meant to do. I want to zoom out, zoom out, zoom out. Oof. Oh, well, I don't want to zoom out that far because it's still a cubic, right? But do you see that as x is getting larger and larger and larger, see, look, right here, all I'm at is x is 4.6, and I'm already got a y value of 100. And if I kept on going, here I've got an x value of 5, and I'm already at 180. So do you see that it's zooming up to positive infinity as your x values are getting larger and larger and larger? And then the next question was, what's the limit as x approaches negative infinity? Well, do you see that your y values, zoom, 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 they're going down very low, right? They're going to negative infinity. And so as x approaches positive infinity, your y values are going to positive infinity for x cubed, and as x approaches negative infinity, your y values are also going to negative infinity. All right, let's look at inverse tangent as well. So I'm going to erase this one. Let's go to inverse tangent. Here's the graph of inverse tangent. Normally we had in fact, maybe should I change that to radians, and your y-axis should go from, instead of integers, how about from negative pi over, how about negative pi to pi, and my step will be pi over 4. Okay. Oh, I didn't want x-axis, I want a y-axis. Dang it. Okay. Negative 10 to 10 and step delete. Okay. I wanted y-axis to be, I remember, negative pi to pi to, come on, you can do this. Oh, come on. Come on. Stupid. Pi over 4. There we go. Okay, so here's inverse tangent. Yes, and they wanted as x approaches positive infinity. So as your x values are getting larger and larger and larger, do you remember when you graphed this guy, there was an asymptote on positive pi over 2? So as x approaches positive infinity, your y values are getting closer and closer to pi over 2. We can look at as x approaches negative infinity. So as your x values are getting, the PowerPoint says smaller, but really it's like larger, but in the negative direction, right? As x is getting larger and larger in the negative direction, do you remember there was an asymptote on negative pi over 2? And so your y values are approaching. They're getting real close, but not touching that asymptote, right? So what are the limits? Remember, the answer to a limit, when they ask you what's the limit, your answer is a y value. So the limit as x approaches infinity for x cubed, it's getting super duper big, infinity. What about as x approached negative infinity? We say it gets way small. I don't like that word. It's actually getting very, very large, but in the negative direction. And so negative infinity. Because if you owe $1 million, you don't owe a tiny amount. That's a huge amount. It's just in the negative, right? You're in the red. Same thing for inverse tangent. As x went to positive infinity, remember there was that asymptote at pi over 2. And then when x approached negative infinity for inverse tangent, it approached negative pi over 2. So again, all of these values are y values. What are the y values as x is approaching these infinities or negative infinities? If the function, like this guy, and like the very first example I gave you, it was a straight line. If it's a polynomial, that's what these guys are called, right? 5x plus 3 is considered a polynomial. It's a linear one, but it is a polynomial. If it's just a polynomial, to find the limit, you just plug in that x value. That's all you have to do. The only time you can't plug it in is when you plug it in and you're dividing by 0 or something. So as long as you can plug it in and actually get a value, then limits are super easy to find. You plug it in. So plug in negative 1/5 into x, and you would have a 5 times negative 1/5, which is negative 1, and then plus 3 gives you 2. Can you plug in a negative 2 and not get it divided by 0? Sure you can. So here again, plug in a negative 2 into x, and you would have a 6 minus, don't forget, negative 2 cubed is negative 8. So you end up with a positive 14. So as long as they're polynomials, then I think that's what if you're dealing with a polynomial function, like we did at the very first one, like when I said to you, you're probably wondering why I'm not just putting a 2 in there. You can actually. 2, you don't, like if I asked you for the limit, you can just plug a 2 in and it gives you a value. It would have given you 4. So the value of the limit is the value of the function if you're talking about a polynomial. When you're talking about a rational function, though, that's when you have issues because you might divide by 0. If a function f of x is a polynomial function on an interval from a to b, these are x values. This is not a point. This is saying from a to b. And if c is a real number on that interval, well, then the limit as x approaches c of f of x is f of c. It's just the technical definition. All it means is you can plug it in. If it's a polynomial function, you can just plug it in, plug it in. But if you plug it in and you divide by 0, you've got to do another strategy. For example, this guy, sine of x over x, the limit as x goes to 0. Well, when you plug in a 0 into x here, you could try it, right? That's what I would always do. Try plugging in a 0, but if you divide by 0, forget about it. When you plug in a 0 into x here, sine of 0 is 0. And when you plug in a 0 into the bottom, you've got a 0. So this is a 0 divided by 0. All right, so you need calculus to figure this out without looking at the graph. And you will learn how to deal with this next year on what happens, because 0 divided by 0, you have always been told 0 divided by anything, 0. But yet you were also told anything divided by 0 becomes a vertical asymptote. It's undefined. But then you were also told that something divided by itself is 1, right? 2 divided by 2 is 1. So which one is it? I've got 3 choices here. I've got a 0 on top, so my answer should be 0. I've got a 0 on bottom, so my answer should be undefined. And I have a number divided by the same number divided by itself, so the answer should be 1. So this is where limits come in. You will learn calculus next year on how to actually deal with this. And it doesn't matter if you go to AB or BC for calculus. You learn, it's called L'Hopital's rule, how to deal with this. But for now, let's look at the graph, all right? And we'll figure out what happens with the graph. Okay. And of course, I changed my settings on here, so it's going to foul it all up, isn't it? Let's see. Fingers crossed. Oh, perf. Yay. All right. Except I do want to change my Y. Can I just reset? Why can't I just reset? I don't. Okay, whatever. And this stupid mofo. Come on. All right, we got how about -5 to 5 and delete that. Okay, there we go. All right, so here is my graph of, this is sine of x over x. Yeah, and so if I click on this point right here, because we wanted as x approached 0, we were looking at the limit as x approached 0. When I click on it, oh, come on. There we go. When you plug in a 0, it's technically undefined. Right there. The graph is just because that's what Desmo says, right? We got an open dot there. But what's the limit as x approaches this guy? Well, if you just look at it like this, if you were up in space and looking at this graph, to me, it looks pretty obvious what your y value is, right? Looks like a 1 to me. And in fact, if you wouldn't have clicked on it to see that it's actually right there showing undefined, there's an open dot right there, you do it. But here's what we do. We look at from the left, as x is approaching 0, coming from this side, your y value is 1. And if you're on the right coming this way, riding it, as x is approaching 0, coming from this side, your y value is 1. And so the limit as x approaches 0 is 1. So it approaches 0 from the right and from the left. It approaches the y value of 1. And so we actually say that the limit as x approaches 0 of sine of x over x is 1. And you'll actually see that function quite often in calc next year. All right. Here's that little clip of Katie saying the limit does not exist. It's a super cute clip. And if you Google it, you could see it's like this little short, 30-second clip of her going, how do I not remember this? Oh, he's so cute, blah, blah, blah. Anyway, all right. I hope you guys have a fantabulous day. today. And maybe. Yep. Okay. Have a good one. Bye.